Let us now discuss the waveform of amplitude modulated wave. Here we can also understand the process of amplitude modulation. Here if this is the device which is AM modulator, in which from one side baseband signal is supplied, which is a low frequency signal, and it is mixed with the other input of this modulator, that is carrier wave, which is a high frequency wave. The output produced, we have discussed, that is an amplitude modulated signal, where the amplitude of the final high frequency wave will be varied according to the information in baseband signal. Here you can see the initial displacement of baseband signal is 0. So the initial amplitude of oscillation for the AM signal will be AC, and when it becomes maximum, you can see the amplitude of oscillations when the baseband signal displacement is maximum will be AC plus AM, and the point where this is becoming minimum, say if this is the time t1 and this is the time t2, here we can see at this time the amplitude of oscillation will be AC minus AM. So here amplitude of the signal is varying according to the baseband signal. Let's discuss once again the waveforms in the enlarged format to understand the amplitude modulated signal. Here by using this picture we can better understand the amplitude modulated wave. If this is the baseband signal and this is the high frequency carrier wave, on superimposing the baseband signal over the amplitude of carrier wave, this amplitude modulated wave is generated, where you can see as initially the displacement of baseband signal is 0, the amplitude of the modulated wave will be AC, and the point where the displacement in baseband signal is maximum, so on superimposing on the carrier wave, its amplitude will be at AC plus AM. Similarly, the point where you can see the displacement of baseband signal is becoming 0, again the amplitude of oscillation in the modulated wave will be at AC. And the point where the point of time where the baseband signal displacement is minimum at minus AM, here you can see the oscillation amplitude will be AC minus AM. So in this situation, if we just draw the envelope of this amplitude modulated wave, here you can see this envelope is an exact replica of the baseband signal. That's why we can say in amplitude modulated wave, the amplitude of oscillations in the wave contains all the information of the baseband signal, that is its frequency, its amplitude as well as the phase. So this is the amplitude modulated wave, which is actually oscillating at high frequency, which we already discussed that its frequency is omega c, and it varies between omega c minus omega m to omega c plus omega m. That also we have studied in the frequency spectrum of amplitude modulated wave. And as all these frequencies are very high, the practical size of antenna required for the transmission of such waves is also small and practical. And for high frequencies, the radiation can be done at sufficient power. So reception will be of good quality. So this is the way how we can understand the waveform of amplitude modulated wave.